Welcome. Let's introduce absolute extrema from a more symbolic approach. So we're not going to rely on the graph of this function on the interval from 0 to 3 or any function on a closed interval to identify absolute extrema. We're going to go ahead and find a way to do that symbolically. So here's a property. Let f be a continuous function over a closed bounded interval I. Okay, the absolute maximum of f over I and the absolute minimum of f over I must occur at the endpoints of the interval or at critical points of the interval. So what this is telling me is that to find my absolute maximum and my absolute minimum, I have to look at two things. I have to look at the endpoints of the interval, and I have to look at the critical points of the function on the interval. So we'll illustrate this with this example. We want to find the absolute extrema for f of x equals x cubed minus 3x squared. And we're looking at the interval from 0 to 3. So based on this property, I need to look at the function values at the endpoints of the interval and at the critical points of the function that lie within the interval. So already I know that to find my absolute extrema, I need to know what f of 0 equals, and I need to know what f of 3 equals. That takes care of what happens at the endpoints. I also must consider what happens at the critical points. I don't yet know the critical points for the function, let alone which ones fall within the interval we're interested in. So let's go ahead and find the critical points for the function we've been given. So f prime of x will equal the derivative of x cubed is 3x squared minus 3 times the derivative of x squared, which is 2x. So f prime of x equals 3x squared minus 6x. Now we want to know what the critical points are for this function and then determine which of those happen to lie within our interval. So we're solving the equation 3x squared minus 6x equals 0. We have a common factor of 3x on the left-hand side. So we have 3x times the quantity x minus 2 equals 0. Solving that, we have 3x equals 0, or we have x minus 2 equals 0. For 3x equals 0, if we divide both sides of that equation by 3, we get x equals 0. Or for this equation on the right, if we add 2 to both sides of that equation, we get the solution that x must equal 2. So we have two critical points for our function, and we only want those that lie within the interval. Now notice that 0 is one of the endpoints. So we're not going to consider the 0 because it's a critical point. We are considering 0 in its role as an endpoint. The question then is, do we have to consider 2? Well, the answer is yes, because 2 is an element of the interval from 0 to 3. So it is possible that we will have an absolute maximum or an absolute minimum at 2. So we will need to also determine what f of 2 equals. So now finding the function values, f at 0 will be 0 cubed minus 3 times 0 squared, which is 0. F of 3 is going to be 3 cubed minus 3 times 3 squared, which is 27 minus 27, or 0. And then f of 2. F of 2 is 2 cubed minus 3 times 2 squared. So that would be 8 minus 3 times 4, or 8 minus 12. And 8 minus 12 is negative 4. And so now we look at these output values to determine the absolute maximum and the absolute minimum. Now the largest of these values, of these output values, is 0. So our absolute maximum is going to be 0, and it actually occurs at 2 locations, at 0 and 3. So we can say the absolute maximum of f of x is 0 at x equals 0 and x equals 3. And then we can say that the absolute minimum, and the smallest of our absolute values is the negative 4. So the absolute minimum of f of x is negative 4, and it occurs at x equals 2. I hope you find this helpful.